How to calibrate a perspective plane. This is a still of a video of a building taken from the ground. And on this building, there was a test conducted. So things were moving around on this face of the building, and we want to measure those and have those measurements be expressed in real-world units. So we need to calibrate this plane. Can't use normal calibration because this plane here is not parallel to the image plane of our camera, but we can use perspective calibration. Let's open up the Scene Calibration Control Panel, and we see that a normal calibration is loaded by default. Let's just turn that off. I'll hide it, and then I'll click the word perspective to create a new perspective calibration. And if we zoom in here to the top left corner to see what's going on, you see that there are 4 points numbered 1 through 4. That's going to indicate to us an order, which we'll get to in a moment. But then you can also see the origin and the X and Y axes. So we want to calibrate this plane by providing 4 points in the plane of motion that have known coordinates. So I'm going to choose some corners here. I'm going to open the settings of the calibration, clicking on the wrench there, and you can see that there are 4 buttons that say set point 1 through 4. I'm going to start by clicking set point 1, and that moves point 1 from up here to where my reticle was, and then I'm just going to do the same thing 3 more times with 3 other corners. Important things to note: this is a rectangle in real life. It doesn't have to be, but it makes it a lot easier if you can find a rectangle with known coordinates inside the plane of motion. The other part, the important part, that they have known coordinates, that's going to help us actually calibrate this. So I have these 4 points set, but now I need to provide their coordinates. I'm going to say that the top left one is my origin, so I'm going to leave its XY coordinates at 0, 0. But after that, let's say that I know that the distance between points 1 and 2 is 40 feet. If I want this to be my X direction, it means that my Y value doesn't change, so I'm going to keep Y at 0. But my X coordinate for point 2 is now going to be 40. Same thing with point 3. If I know that the distance between points 1 and 3 is again 40 feet, then I'm going to change just the Y coordinate. Note that it's still positive because our positive Y direction points down. And then for our last point, I'm going to change both the X and Y coordinates, and then I'm going to make sure that my units are in feet, something real world. And then I click apply and close, and you can now see that we have a calibrated plane. Not only do we have our X and Y axes aligned with the grid of this face of the building, but also our scale is set. So when we take measurements of things moving on this face, they will be mapped to this coordinate system and expressed in real-world units.